So hey guys, there you are. I warmly welcome you all to my channel Abbot Academy. So this time we'll be dealing with a very important topic, that is quantum numbers. So quantum numbers is a topic in which very students get confused, and we will be talking about quantum numbers in detail in this video. So stay tuned at Abbot Academy. So basically there are four quantum numbers, that is N, L, M and S, and this video will make you an expert in quantum numbers. That's my guarantee. So stay tuned guys. So, hey guys, now we will discuss about the principal quantum number, that is denoted by small l. So, what is basically principal quantum number? Principal quantum number, as a name suggests, principal. So, it is the main quantum number, you can say. With this, by knowing this, just principal quantum number, you can tell everything about the electron and everything about the all the other you can say the shells are related to it. So, let us talk about it. So principal quantum number, by knowing just the value of n, I can guess the size of the shell. The shell number, of course, it gives us the shell number to which the electron belongs. The energy of the shell. So as you read in the Bohr's atomic model, that by knowing the n, we can find the energy of the shell, and we can further find the radius of the shell, which is nothing but the size of the shell. So it an important information. It only takes the integer values and not it only takes integral values. Okay. So this is the principal quantum number, and now we will come to the azimuthal or the L quantum number. So guys, now we will be looking about the azimuthal quantum number. So azimuthal quantum number, it is a very important quantum number, and it basically tells about the subshell. Okay, if you ever come across the azimuthal, it is denoted by the small l. So quickly you should be able to see that, determine that it is talking about the subshell. Okay, so what does it tells? It again tell about the three things, that is orbital angular momentum. So by using L, you can tell the orbital angular momentum, and the formula is under root L into L plus 1 h upon 2 pi. So by using the values of L, you can tell about the orbital angular momentum by this formula, L into L plus 1 into h upon 2 pi. So as I said that L denotes the subshell, azimuthal quantum number denotes the subshell. So there are four subshells, S, P, D, F, and there is a very important thing that you should know first, that in any atom there is a shell, and in the shell there are subshells. There are four subshells, S, P, D, F, and then in the subshells there are orbitals. So basically shell, subshell, orbitals. For example, if there is your address, so you live in India, that is India is your shell. Again, you live in which state, that is your subshell, and where your locality or your society's name, it's your orbital. So again, shell, subshell, orbital. So it tells about subshells. Now SPDF, and the values, if there is an value of n, for example 1, 2, 3. So how can we determine the values of L in terms of n? So basically there is a formula to determine the values of L. So L again takes integral values which lie between 0 to n minus 1. For example, there is n is equals to 4. So how many values of L will there be? So there will be 0, 1, 2, 3. So these all values L can take. Okay, 0 to n minus 1, where 0 is included and n minus 1 is also included. So if n is equals to 3, L can take 0, 1, 2. Okay, so 0 to n minus 1 and 0 included and minus 1 included. Now, there are some certain values of L which are very important, which determine the subshells. Okay, so for example, if you come across any value of L, that is 0. So L is equals to 0 denotes S subshell. Always remember that, it's very important. L is equals to 0 denotes S subshell, and L is equals to 1 denotes P subshell. Okay, L equals to 0, S subshell, and then L is equals to 2 denotes D subshell, and L is equals to 3 denotes F subshell. So whenever you find L is equals to 0, S subshell, L is to 1, P subshell, L is equals to 2, D subshell, and L is equals to 3, that is F subshell. So basically L can take 0 to n minus 1 values, and it tells about the orbital angular momentum. And if you come across any of these values, and so you should be able to code it, that it is determined in the subshell. So these are 4 subshells, S, P, D, F, and there are 2 more, G, H, but we do not use them commonly, so you have to remember that. It's important. Let's move on to the third. So now let us come to magnetic quantum number. So what is magnetic quantum number? Magnetic quantum number is nothing but the orbital. Simply, it's nothing but the orbitals. So magnetic quantum numbers tell us about the orbitals. So as we have discussed earlier, that n tells about the shell, L tells about the subshells, and M tells about the orbitals. So it is again and takes integral values ranging from minus L to plus L. So let us summarize what we have read till now. We have read that n tells the subshell and L tells the subshells. N tells the shell and L tells the subshell, and L takes value from 0 to n minus 1, in which 0 included, n minus 1 also included. Now, how to determine the values of n, that is magnetic quantum number? So M takes values minus L to positive L. So minus L to positive L. So example, if I have L is equals to 3. So what will the magnetic values for it? So M will be minus 3, minus 2, minus 1, 0, 1, 2, 3. So these values minus 3, minus 1, 0, 1, 2, 3 are what? These are orbitals. So let us come to one more example for clarity. For example, L is equals to 2. So minus 2, minus 1, 0, 1, 2. And will have minus 2, minus 1, 0, 1, 2. And these are the orbitals. So let us draw a table in the next page. So it will be a table that will summarize all we have read, and it is a very important table. So mark it in your notebooks. So in front of us we have a table which has N, L, and M. So we have 3 quantum numbers. So first we will revise what we have read till now, because it's very confusing sometimes. So let us draw tables, and this table will clear all your concepts, and it will help you to memorize the things. So for example, N, let us take a value of first shell. So that is K shell. Okay. So now as we have read it, L can takes minus N to plus N. So the values of L will be 0 to n minus 1. So 0. Because 0 to n minus 1 is, then if the value of n is 1, then 0 to 0, that is only 0 only. Now M can take minus L to plus L, that is 0, because minus in 0 that can be never minus or plus, so it is 0 only. Let us take n is equals to 2. So now L takes 0 to n minus 1, that is 0, and n minus 1, that is 1, because 2 minus 1 is 1. So L can take 0 and 1. And what can n take? Let us write beneath it. Okay, now for 0 the m will be 0, and for 1 m will be minus L to plus L, that is minus 1 to plus 1. So minus 1, 0, 1. Now as we have read that if their values of L will be 0, then it will be S subshell. I have made you remember that if L will be 0, then it is S, if L will be 1, that is P, and so on. And again it is S, it is P, because if L becomes 1, then it is P subshell. If n is 3, then again the values of L will be 0 to n minus 1, that is 0 to 2. So 0, 1, 2. And for example, it is 0, minus 1, 0, 1, because minus L to plus L, and again minus 2, minus 1, 0, 1, 2. So let us quickly write S, P, D. Now I would have tell you before the formulas for finding all these, the relation between shell orbitals, the relation between the shell and the electrons, and so many formulas. But I want you to understand all the concepts instead of just memorizing all the formulas. So in this video you will understand all the concepts instead of memorizing the formulas. So by this table you will also memorize the formula itself by just understanding it. So please stay tuned. So first, making an observation, we can say that if there will be first subshell, then there is only one subshell. If there is one shell, then there is one subshell. If there is two shell, if there is the second shell, that is the n is equals to 2, then there will be two subshells. We can clear it at S and P. So n is equals to 2, therefore 2 subshells. When n is equals to 3, then we can say that there are 3 subshells, S, P, D. So we can say that number of shells, the value of n is equals to the value of subshells. So if n will be 4, then subshell will be 4. If n will be 5, subshell will be 5. So now the value of n is equals to the number of subshells. Simple. So we have first derived the first formula, mark it in our notebooks. Then second formula. We can clearly see that if there is 0, if L is 0, then the value of M is 0. Simple. So as I have already said that the value of M denotes the orbitals. So in the first subshell there is only one orbital, because there is only one value, that is 0 doesn't matters. It tells that there is only one value. Okay, there is one value, there is 3 values. So we will not be looking -1, 0, -2. We'll counting the values. How many values are there? The values only tell us about the orbitals. So there is only one value, that is there is only one orbital. In the first subshell, that is S subshell, there is only one orbital. And in the second subshell, that is P. So there are three values. So we can clearly say that there are 3 values. In the third subshell, that is D, there are 5 values. 1, 2, 3, 4, 5. So there are 5 orbitals. So now we can conclude a formula that the number of orbitals is equals 2 into L plus 1. Simple. So because always an odd number is coming, so you can derive this formula on your own also. So number of orbitals will be 2 into L plus 1. For example, L is equals to 2. Put this value, you will get only one orbital. We are getting one orbital. L is equals to 2, L is equals to 1. For P, you will get 3 orbitals. So we are getting 3 orbitals. So this formula is correct. So for determine the values of M, you can use this formula 2 into L plus 1. That is what tell you about the values of the orbitals. Now we have seen that. Now let us see the relation between orbitals and the shell. Now we can see that there is only one shell. So there is only one orbital. There are 2 shells. So there are 4 orbitals. The shell number is 3. So there are 9 orbitals. You can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So for 2, n is equals to 2, there are 4 subshells. For n is equals to 3, there are 9 subshells. So what can we conclude that? We can conclude that the number of orbitals is nothing but n square. For the second shell, there are 4 orbitals. For the third, there are 9 orbitals. So the number of orbitals is nothing but n square, or the value of n, just square it. So for 3, there are 9 orbitals, just square the value. Now we have also derived the relation between the n and the orbitals. Now let us move on to another thing. Isn't it incomplete? Yes, it is incomplete because S is same, but now you have to mark the shell number. So for the shell number, we just write first, because the S belongs to the first subshell, the first shell, so we'll write about the first. Now this S belongs to the second shell. If we write 2 in front of it, and P belongs to 2. Now this S belongs to the 3. So third shell, third shell, third shell. Now it is complete. We always write the shell first, the shell number first, and then the subshell. Now it's complete. Okay, so this is the common form of writing the shells and the subshells. This will help you in the electronic configuration. So basically we have derived the formulas that the number of the shell number first, and for the shell number we can find the orbital, that is nothing but n square, and the values of m can be found by the formula 2 into L plus 1, and the number of subshells directly depend on the value of n. If there is one value n is equals to 1, then there is only one subshell. Simple. So let us move on to the fourth, that is spin quantum number. So now for spin quantum number. Spin quantum number is the fourth quantum number, is denoted by S. Now S can take only 2 values, that is positive half and minus half. So this is basically a convention, because we can consider that the electrons rotate in anti-clockwise and the clockwise direction. So for anti-clockwise we consider it as minus half. We can also consider it as plus half. It's just a convention. That's for anti-clockwise it is minus half. For clockwise it is positive half. So it's a convention. You can also consider positive half for clockwise, for anti-clockwise. So for clockwise we consider positive half, and for anti-clockwise we consider negative half, because clockwise and anti-clockwise represent the opposite. So we determine them with opposite signs. So basically the clockwise or anti-clockwise direction is the direction of the electrons which are rotating in the orbitals. So for if an electron is rotating, we use a positive half for clockwise and negative half for anti-clockwise. Just as simple as that. Nothing much complex in this. It contains only two values, plus half and minus half, for representing for the electron their opposite spin, representing their opposite spin. Nothing much complex. So this was the four contact number that was very important. And if you like my video, then please like and subscribe my channel Abbot Academy, and please support guys by subscribing that red button. Thank you guys.